Okay, so we're going to look at example 4 from the notes that I didn't get a chance to complete in class. And so make sure you put this in your notes. In looking at this problem, so we have to simplify this rational expression, right? And it's a lot going on here, but if we take it piece by piece and then bring it together, then it won't seem as overwhelming. So we should simplify the numerator first, then denominator, then we're going to bring everything together. Okay. All right, then bring everything together. All right, so if we just take our numerator, we see we have x over x plus 1 minus 1 over 3x plus 3. Okay. So what we need to do is examine the denominators and then find our least common denominator. So just looking, so our denominators, we see our x plus 1 and 3x plus 3, which that will equal, we can factor that, right? So that's 3 times x plus 1. Okay. So in essence, in finding the LCD, the least common denominator, we just bring together all the different terms in all the distinct terms in our denominator, right? Okay. And so that would be 3 times x plus 1. Okay. So in other words, our LCD is 3 x plus 3. If you want to keep it, you can keep it either or. You can keep it as since we're simplifying this expression, when we're done, we'll have to distribute everything back through. But if you want to keep it as this quantity here for now, you can. That's fine. Okay. And so from here, we need to find the create equivalent fractions, because this is subtraction, and in terms of addition and subtraction, you can only add or subtract the same things, right? And so we have to find common denominator. Well, we see here in the second expression, the second term, that 3x plus 3 is already in the denominator. So we just need to create a common denominator here. And x plus 1 is already in the denominator. So we just need to multiply. Of course, we need to multiply by a form of 1 because we don't want to change the expression, right? 1 times anything is still that anything. It's not changing our expression. So that's important. And so, what am I doing? No, not that. Okay. Over x times x plus 1. And so we have, this is 3x over 3x plus 3. Okay. And so in our numerator, we're going to have 3x over 3x plus 3 minus 1 over 3x plus 3. Now we can bring them together. So we have 3x minus 1 over 3x plus 3. And you know how I said, for me, it's really a bad word to say cancel. And so one of the reasons why I say that is because a lot of students, I see this all the time, but I know you're not doing this, just say, oh, we can cancel those 3 x's and now we get negative 1/3. No, right? Because remember, I gave you the rules on the first page when I said how to simplify a rational expression. The numerator and the denominator needs to be factored first. And factor means something times something. These both aren't factored. Now we know here we could pull out a 3, right? And we already know that's going to be 3 times x plus 1. But that's not going to help us because in the numerator we can't factor out. There's no common terms in those, right? So we can't factor out anything. So this will be our final answer. So this, for now, right, is our final answer for the numerator. Okay. So now let's go to the denominator. Okay. So now here's our denominator. And what I would suggest is putting a 1 there so you can clearly see that fraction. And when you have to, because it's subtraction, so we're going to have to create equivalent fractions. Well, the LCD for this one is straightforward, right? Because the denominator is just x and 1. So the LCD is just x times 1 or x. Okay. And so here, all we need to do is multiply. I'll do it over here. this over here by our form of 1 in this case will be x over x, right? And so what that'll give us, and I'll put it, let's put it all together. So we'll have x plus 3 over x minus 2x over x, right? Well, what does that equal? Since they have the same denominators, we can bring this together. This is x plus 3 minus 2x all over x, which is what? Negative x plus 3 over x. And again, I know I'm not seeing any of that, right? Because that is illegal. Because it's not factored, and we can't factor any further. So that's just our denominator. So now bringing everything back together, we have what? Okay, so we have this. So our numerator, again, we simplify that to 3x minus 1 over 3x plus 3 all over this denominator here. And I just didn't want to have the negative term leading. So that's why we wrote it as 3 minus x. If you want to keep it as negative x plus 3, that's fine. It's the same thing. All right, all over x. Now remember, division is multiplication by the reciprocal. Okay, and it's always the reciprocal of your denominator, right? You're never flipping your numerator. It's always the denominator. So this will become 3x minus 1 over 3x plus 3 times what? X over 3 minus x. And this is where, so you know how I said you may want to, so you don't necessarily, you can just look at this. If you want to write it down, you can. You really don't need to. But in this case, well, a couple things. First of all, everything is being multiplied, right? Multiplication is so simple and easy because you don't have to worry about having similar terms to multiply. You can multiply anything by anything. And so the numerator, and I'm putting parentheses here, I just want to make sure I emphasize something. And again, this isn't necessary. You don't have to write this down. You could just keep what we have above. So as you can see now, everything is factored in the numerator. Everything is factored in the, it's factored, right? Something times something in the numerator, right? It's something times something here, right? And then it's something times something there, right? So everything's factored. Now you look for any common terms in the numerator denominator. There are no common terms, right? So there's no way we can simplify this any further as far as factoring off a 1, right? Removing an unnecessary 1. So since we know that, and that's where it may be beneficial to keep this unfactored until you can clearly see that it's not simplifying or or you're not removing any unnecessary 1s. And so now we can multiply through. So our final answer will be 3x squared minus x, right? All over, I'm going to multiply that 3 back through. And let's see. So our final answer is, so I want you to, I actually skipped the step because I want to make sure you understand it. So you should do this on your own. But our final answer should be 3x squared minus x, okay, divided by 3x squared plus 12x plus 9. Okay, so I realized I made a mistake here. For some reason, before I erased it now, but it was a plus there. And so I did work assuming that was plus, but it should be 3 minus x. So what I want you to do now is finish simplifying, pause the video, finish simplifying, and then when you come back, you can check to make sure your answer is correct. Welcome back. So your final answer is here, 3x squared minus x over negative 3x squared plus 6x plus 9. And again, we already know that this is our final answer. We can't go any further. So please don't be tempted to want to do some illegal canceling because we know we have factored it already, and we saw that there were no 1s that we could remove. And when I say 1s, I mean if there was like an x over x, that's a formula. That's a 1. That's a 1 that we can remove. So that's what I mean. Okay. So I want to look at one more problem just to make sure you're good. So write this somewhere in your notes as well. Okay. So I want to do one more example. And you're I think when we do this problem, you'll see why I wanted to do another example just so you can become comfortable. It's similar to what we just did, right? And so looking at our numerator first, so we have 5 over 2p plus 1 over p, right? Okay, so again, the denominators are not like terms, so we need to make it like terms, but it's simple because it's just going to be 2p, right? So 2 over 2, and that's, so 5 over 2p plus 2 over 2p. Now they're the same, right? So that gives us what? 7 over 2p, okay? And then, let's see. That's the numerator, and we can't do anything else, right? It can't be simplified any further. Let's look at the denominator. So 1 over 4p minus 5 over 6. So here again, we have to be a little more careful here though. Okay, and what I mean by that is it's 4p and 6, and it may not be that clear on what the LCD is. So if you have numbers, even with letters, if it's like p squared or p cubed or whatever, you might want to expand it out. For numbers, you might want to break down into their primes so you can clearly see what's repeating and what's not, so you'll know what to do in your LCD. So if we take 4p, right, that's 2 times 2 times p, all right, that's its prime factorization, and then times p, of course, and then for 6, it's 2 times 3. So then the LCD, because we don't include any repeats because we're looking for the least common denominator, they both have a 2, so we just bring over 1, 2. And then, actually it has another 2, right? So we bring in, because we're sort of looking distinctly. So it's 1, 2, so we just bring in 1, but then this one has a 2, right? And then there's a 3 and there's a p. So 3 and p. And so if we multiply that together, the LCD is, what's that? 12p. Okay. So we have to make common denominators for both here, unlike the first problem where we only had one that we had to change because the other one was already in its form. All right, so let's look. Well, 1 over 4p, we're thinking about 4p times what will give us 12p. Well, if we multiply it by 3/3, what form of 1? That will give us our 12p. And then because of space, I'm going to do the 5, 6 as well. So this would be what? 2p right here. Okay. And so here we get 3 over 12p minus 10p over 12p. Okay. And so that's 3 minus 10p over 12p. Okay. And again, nothing can be factored in the numerator. There's no common factors in the numerator. And so we'll just keep it like this. So now let's bring everything back together over here in the beginning. So our numerator again was 7 over 2p, all divided by, and I like to, when I'm dealing with rational expressions with division, I like to make sure that line divided, the numerator and denominator, is longer, so I can differentiate between what's my numerator and what's my denominator. And the importance of that is, remember again, division is multiplication by the reciprocal, by the flip, right? You flip the denominator. So this is going to be 7 over 2p times 12p over 3 minus 10p. Okay. Now we want to simplify this completely. So I'm looking to see, this is what's important. I'm looking to see, all right, in my denominator, right? I see my denominator. That 3 minus 10p doesn't look like it's going to go anywhere, right? Because it's nothing that's in the top that looks even close to a 3 minus 10p. But in my 2p term, okay, it looks as though something here can be simplified, right? And so whichever one is the larger value in terms of looking at the number. So in this case, the 12p, I want to think about, can I rewrite, in a factored way, or something times something, so that 2p is involved in the numerator? Because if I can get a 2p at the top, then I can remove that unnecessary one. Okay. And in fact, we can. So what will happen is this will be 7, and this is multiplication, right? So we can multiply straight across. I'm going to add parentheses into 2p, and then 2p times what will give me 12p? Well, 6, right? All over 2p times 3 minus 10p. All right, again, it's multiplication, so we can multiply straight across. Look at that. That is so pretty, right? 2p over 2p, that we remove that unnecessary 1, and what will we be left with? So our final answer is 7 times 6 is 42 over 3 minus 10p. All right, so I hope this makes sense. And I am done with this video. I will see you all in class.